try something else. Is 51 prime? There's a somewhat well-known story. Probably one of the most powerful mathematicians that lived in the 20th century. His name was Grothendieck. Really interesting guy. Totally changed the way we think about something called topology. Groundbreaking work. He had this center where all of like the most elite European or French mathematicians would work out in the French countryside. And then this, making tremendous progress from like 1960 to 1975. But then at some point he became convicted that somehow the money that was funding him was somehow derived from the military-industrial complex, at which point he threw up his hands in despair and became a hermit. So it's interesting. But he apparently, in some lecture somewhere, he was asked to give an example of the thing he's doing. Like, what's a prime that's an example of that? And if the story is correct and not, wrong, he said 51. Which is funny, because 51 is not prime. What is 51? What's 51? 51 is actually 3 times 17, right? But this is, it's kind of tough, isn't it? How do you know 51 is 3 times 17? What? How do you do that, right? Your textbook has this really cool story about this mathematician, back in the 1903 AMS Society. He just went up to the board, right? He went up to the board and a chalkboard, this giant lecture hall, and he wrote 2 to the 67 power minus 1 is this number. I won't try to verbalize it, right? And then he went to the board and he put this number and that number, and then he multiplied them out, long form, right? And then the product of this number and that number is equal to that number, which proved what? It proved that 2 to the 67 minus 1 is not prime. Now, oftentimes 2 to a power minus 1 is prime. So finding 2 to a power minus 1 not being prime is interesting in itself. But my point to you guys is that finding prime factorizations of numbers is a big deal. All right, so how do you find the prime factorization of a number? What are strategies for doing that? Well, there are various strategies, right? So how to find prime factorizations. So one strategy is to use like a tree diagram, right? So you start with the number you're interested in, something like, I don't know, let's pick a number, any number, 246, all right? And then, well, if it's even, that means we can pick a power of 2, right? What's 2 divided by 2 divides into 246? What do we got? 123, yeah? And then how about 123? Is 123 a prime? So I try 123. So here's a theorem. N composite has divisors smaller than the square root of n. Let's say approximately, it could be the square root of n, okay? But the point is, you only have to test up to the square root of the number. All right, so to check if 123 is prime, that means that we need to check for 123, we need to check, well, it's obviously not divisible by 2, right? So we need to check 3, 4, 5, 6, 7, 8, 9, 10. What's 11? What's 11 squared? 121, right? What's 12 squared? 12 squared is 144. That means that there has to be if there is a divisor of 123, there has to be one in here. So did you guys find it? Does it have a divisor? If you divide by 3, you can do that, right? So it's 3 times 41. Is 41 prime? For 41, to see if it's prime, all we have to check are, in principle, 2, 3, 4, 5, 6, and 7. Not even 7, right? Because 7 squared is what? 49. So that's too big. We don't even need to check that. These are the, if 41 was composite, it has to have one of these divisors, right? Obviously, 2 is not a divisor because the ones digit is 1, right? So you can scratch that out. So we only need to check 3, 4, 5, and 6. What's 41 divided by 3? It's my stupid calculator tells me 41 over 3. The point is it's not an integer. 41 over 4. Not an integer. 41 over 5. Obviously that's not an integer. 41 over 6. Not an integer, right? So hey, 41 is prime. And so what we have is that 246 is 2 times 3 times 41. So we can use this kind of approach to find the prime factorization of a number. Now, you guys are getting restless. So, I mean, we still have till like 11:30, right? I'm just messing with you. So, listen. I should probably talk a little bit more about prime factorizations next time, but I'll just tell you this much. Prime factorization is really important. Ultimately, you know encryption? Do you guys know what encryption is? Like what allows you to send emails securely and do banking online, stuff like that? All of that is ultimately based on prime number factorizations like this. So I'll talk more about that next time. I think we should. So thanks, guys. Have a good weekend.